Right, welcome to our first online video lesson for Level 2 Maths. This week I'd like us to look at solving simultaneous equations like we have done a little bit of in class. I'm sure that most of you do not have the textbook at home, so I am also going to scan through some pages to you through Teams. If you have the textbook at home, of course that's brilliant, but for those of you that don't, I'll scan them as well as other scanned worksheets from the variety of other books that I have here at home. So there should be plenty for you to work on. Do what you can when you can. So, solving simultaneous equations. Simultaneous, of course, means that we are solving multiple equations together at the same time. There are a couple of key methods that I would like us to go through today. First of which is substitution, which most of you are probably more familiar with and more comfortable with. That's absolutely fine. I just want us to be aware of two methods, and you can pick what is easiest for you for any given question that you come across. So, substitution, of course, just means replacement. So if we have a couple of equations, you just simply place one into the other and replace a given variable or value. So, let's start with an example. We might have two equations. First one might be 2x plus y. Let's say that equals 12. And our second equation, let's keep this simple, might be 2x minus 3y. And let's say that's going to equal 28. So, we've got a couple of different options here. First of all, I see that in both equations, I have a 2x. That is common to both. I also see that in my first equation, I have a simple y, just a single y. I could easily rearrange that equation to be y equals. Or I could easily get rid of my 2x's somehow, because they are the same, and work with substitution either way. I'll show you both. First of all, let's rearrange so that we have each equation as equal to 2x. Now, if you're not comfortable with rearranging, I suggest you definitely practice some of these skills. So, first equation, shifting the y to the right-hand side by subtracting it. Second equation, we want that to also equal 2x by adding 3y to both sides, always doing the opposite function. So, those are our two new equations. Nothing has changed except for the order in which they are written. Now, substitution, of course, was replacement. If I have 2x in both, I see that if both are equal to 2x, they are both, these two expressions here on the right-hand side, they are both equal to each other. So our next step would be to say that 12 minus y is equal to 28 plus 3y. Because if they are both equal to the same thing, they must be equal to each other. They equal the same thing. From here, we have now one equation with only one variable, which means we can solve it. The reason why we needed to do substitution in the first place was because we had two variables that were unknown in an equation, so there's nothing I can do with it, unless I have a second equation with those variables, in which case I can find a solution. Now that I have a single equation with a single variable, in this case y, I can move on. I want to rearrange everything so that it's just equal to y, because I have a negative on the left-hand side and I would prefer to work with positives. I'm going to move that to the right-hand side. So my next step would be to add y to the right-hand side. That would leave me with 4y. And in the same step, you could split them up if you need to. In the same step, I'm going to get rid of my 28. It's currently positive, so I will subtract that and move it to the left-hand side. So of course, we have 12, take away 28, which leaves us with negative 16 on the left-hand side. Much simpler. My final step in this process is to get y equals, so I need to divide by 4. Negative 16 divided by 4 leaves us with negative 4. and that is y. Now I'm not actually done yet. That was the final step of this part. But I also need to find what x equals, because I had two variables to begin with. So my next step is to say that if y equals -4, because I must always communicate what I'm doing, that means that, and I'm just picking the first equation to work with here, 2x plus y, which in this case is -4. So I am replacing y with -4. That means that that will equal 12. Now, of course, I could have used this version of the equation, which is really just what I'm going to next. When I say that 2x, this is essentially subtract 4, not just add -4. That would equal 16 on my right-hand side now. If I'd done it from this step here, I would have 2x equals 12, take away -4. Be very careful of the double negative. That would have looked like this. 2x equals 12, take away -4. Just make sure that you don't lose one of those negatives along the way. Moving back onto here, dividing by 2 leaves us with the result of x equals 8. The only thing that remains is to actually communicate the solution. We know that x values and y values are written as coordinates. So the solution is that x equals 8, y equals -4. Done. So, the second way of doing this particular problem, you could do them either way. I don't mind which you choose. This one that I'm about to do could be simpler for you. Note that at the beginning, I said that this particular equation, the first one here, because it had a singular y, could very easily be rearranged into y equals as a format. Keeping my y on the left-hand side because it's already positive, I will now move my 2x over to the right-hand side by subtracting, leaving me with y equals 12 minus 2x. My second equation remains as is. 2x minus 3y equals 28. Now that I've rearranged this first equation into a y equals format, I can substitute it into my second, because if y equals this, let's put that in a bracket to visualize it, then I can say that 2x minus 3 of whatever y is, in this case 12 minus 2x, then I can simply replace it, and the second equation still all equals 28. Moving on from this, again, we now have a single equation with a single variable. In this case, it's x. On the left, we were working with y. It doesn't matter. Both will get you to the same answer. We should see that, again, we get 8 -4. So we now need to expand this equation. I'll leave my 2x there for the moment, but this will get me 2x minus, of course, 36 plus 6x is still equal to 28. We need to tidy this up a little bit. 2x plus 6x is 8x. Leave my 36 there just for the moment so I don't lose anyone. So all I've done is combine like terms. Now I need to move my 36 or -36 to the right hand side so that I'm isolating the x's. So of course that means I need to add 36 to my right hand side by doing the opposite function, which leaves me with 64. Finally, to get x by itself, I divide by 8. And we of course know that 8 squared is 64, which means that x equals 8. Just like with on the left here, we're not done yet. We've only found one part of the coordinate. So, once again, communicating what I'm doing. If x equals 8, just like I said, if y equaled -4 on the left-hand side, I can now substitute it into any of these equations that I've been working with. Because I'm trying to find y, I'm going to substitute it into that rearranged equation. So I said that x equals 8, so I'm replacing x with 8. To tidy that up, 2 8s are of course 16. So 12 minus 16 leaves us with -4. Funnily enough, that's exactly the same as what we got on the left, as it should be, meaning that the final solution is still, like we solved before, at 8 -4. All done. Now, that's just one example, and it's an example of a relatively easy problem. We had quite low coefficients here, and I had the opportunity to rearrange it if I so chose. Both of these are also straight lines. If you've got your graphics calculator, or if you have graph paper and felt like graphing any of these, you would find that they were two straight lines that intersected at a single point. Hence that there is only one solution, because these two lines only cross at one point. But what we know from our work in class, even if that was about a month ago, is that we can also work with non-linear equations. So let's do a second example and step it up a notch. We'll keep it relatively simple while making sure that we are making progress. So let's just work with a simple parabola. Those of you that did all right with this work in class will know that this is quite familiar, but some of you did struggle with it, so bear with me as I go through this and hopefully it'll make a little bit more sense. For this example, let's work with a parabola and a straight line, so only one of these is a curve. Now, luckily at level 2, for this particular internal, which was that little bonus 2 credit one that we'll still work on doing, the solving systems or systems of equations or simultaneous equations would go no further than one curve. You would not be required to solve where two curves intersect. That's a little bit too far for level 2. So you'll always have a straight line to rely on. Possibly not this simple, but you get the idea. Now, even though this is a curve, very nicely enough, we have both of these equations set as y equals. So we're basically doing the combination of everything we did on the left. I have two things that are equal, which means that both of these expressions on the right-hand side must be equal to each other, just like how we did here. The only difference is that it's y, not 2x. And basically, we're doing the same thing as we did on the right, where we're saying that whatever y equals, we're going to slot that in to y in the other equation. So my next step is simply to say that x squared minus 2x minus 3 from my first equation is equal to x plus 1 from my second equation. This is still just substitution. Now I know that this is a quadratic because I have a power of 2 here. It's in polynomial form, but in order to solve a quadratic I must set it as equal to 0, which means this right hand side I need to shift. So there's no other x squared term, so that has to remain. Negative 2x subtract another x leaves me with negative 3x. Negative 3 subtract my 1 from here gives me negative 4. And now I have a quadratic that equals 0, meaning that I can factorize and solve it. Factorizing, of course, putting it into brackets. A quadratic, meaning there are 2 brackets. Remember your FOIL expansion to check in case you're not so flash at factorizing. We need 2 numbers that multiply to negative 4. Those go in the final parts from the L in FOIL. And we need those same 2 numbers to add to negative 3. Because I only have a single x squared, I know that both of these brackets simply begin with x. There is no funny business or coefficient in front of either of these. Thankfully, we've got relatively small numbers. The only factors of 4 here would be 1 and 4 or 2 and 2. There's no way that 2 and 2 would make 3, any combination of addition or subtraction, so I know that I must have 1 and 4. Looking at the direction of -3 here, the bigger number has to be the negative to make all of this negative. And because this here, my -4, is a negative, only one of these can be a negative number, a subtraction. Otherwise, this would have reverted to a positive. So you've probably got the answer already, that x must be -1 and 4, because those are the two values for which this expression could equal 0. Note that now there are two values of x because we had a curve instead of just finding one in the first example. That's because in the first example, as I described, we have two straight lines of some sort. They only can cross once. Here, I might have some sort of parabola. It could cross up to twice. Of course, those are just sketches. They are not actually accurate drawings. So, for these two, I need to work with both. First of all, if x equals -1. Secondly, note that I'm saying and instead of the or that I did in the first. Or from the first, you had the choice of what you were most comfortable with. And from the second means that you must do both. X does equal -1. Whoops, I wrote y, I mean x, does also equal 4. Doesn't matter which one you work with first. You might have written these brackets around the other way. It means the same thing. But you do need to work through both still. So first of all, if x equals -1, then we need to substitute into either of these equations. Of course, the second one here looks a lot simpler, so I'm going to choose to use that. Now, x equaled -1, so I replace x with that. That means that y equals 0, and therefore my first solution is that x equals -1, 0. Note that I'm saying it's the first solution because I know that there's a second one to come now. So secondly, if x equals 4, I can use the same equation again, but substitute the new value of x, which was 4. I'm still adding 1 to it because I'm using this second equation. So y now in this situation equals 5, meaning that my second solution is that x equals 4, y equals 5. Two solutions because you have a curve and a straight line. All of that is substitution. Moving on to elimination. I'm going to start by working through the exact same problem that we did at the beginning. Same equations, just repeated, and I'm going to do them a different way to show you what's possible. Perhaps the method that we chose first, substitution, seemed a little bit complicated for some reason. This is just an alternative. It is completely up to you. I have those same equations here, 2x plus y equals 12 and 2x minus 3y equals 28. For the purposes of this process, which is elimination, where we're looking for a common value, I'm going to find it easier to label my equations. This is something I do personally like doing. Colour coding would work just as well, and you don't actually have to do this. It just helps to keep things in order. What I notice here, just like I said in the first method, I have 2x in both of my equations. That is the common value I'm speaking about in this note at the top. If I have a common value, I can eliminate it. So what I'm going to do is to actually subtract all of equation 2 from 1. And that's why it's handy to have some labels. They get used a little bit further on as well. It basically just communicates what you are doing and why. I might lay this out like this. I'm using square brackets just to denote that I am capturing all of an equation. They mean nothing different to a normal rounded bracket. They're just usually used to house something larger, a large equation or a big expression in some way. And I'm laying this out like you would in arithmetic subtraction. So, working from left to right, doesn't matter, I could work from right to left because they are all treated separately. I see that 2x minus 2x is, of course, 0x. Y minus negative 3y leaves me with positive 4y. Be careful with those double negatives. I subtracted so that I could get rid of something overall and result in a 0 somewhere. If for some reason this was a negative 2x, I would do the opposite and add the entire equation. So just be careful with what you're doing. Now, of course, I need to also subtract 28 from 12, so that leaves me with a negative 16. From there, we can say, because we don't need to write our 0x, that 4y simply equals negative 16. We've seen the similarities over here on the left-hand side. It's exactly the same set of equations, so we should be getting the same answer yet again. This means that y equals negative 4. Now, though everything that we've done in this method so far has been elimination, the final step is always substitution, which is exactly why I did substitution as our first method. We need to substitute y equals negative 4. So, again, it doesn't matter which equation. I'm just going to choose the first one there. 2x plus y, where y is negative 4, equals 12. Tidying this up, moving my negative 4 to the right-hand side by adding it, leaves me with 2x equals 16, dividing by 2 leaves me with x equals 8. Therefore, my solution is that x equals 8, y equals negative 4, consistent with the substitution method. Now we've used elimination. It's completely up to you which one works best for you. However, there are some cases where elimination is the easiest. So far, just like I said at the beginning, most of you have probably found substitution to be easier because you don't have to worry about this labelling and huge bracket nonsense. However, take a look at the second example that we're going to do here, the last example for this lesson. If I have a slightly more complex set of equations, let's say we have 4x plus 3y, and that might equal 17. And as our second equation, let's have 5x plus 2y, and let's say that equals 23. Take a look and see what's different about this set of equations to our first set. Now, neither of these are a curve. That's different to what we did as our second example with our first method. They are still straight lines. However, the coefficients are all different. With our first example, we had 2x in both equations, so we didn't have to make any adjustments before beginning. We could just subtract something right from the get-go. We can't do that here, because if I subtract 5 from 4, I don't get my 0 that I'm looking for. Likewise with the y's. I'm going to need to change something. Of course, we also noted that with this first example, it would have easily been rearranged into y equals. That's not so easy over here because none of these are just x or y singularly. So you would have to divide if you want to rearrange it into x as the subject or y as the subject of the equation. That's why for this particular example, elimination probably is the easiest. So, if there's no common factor, we multiply to create one. Again, I'm going to label these equations 1 and 2. To find my lowest common multiple of any of these variables, x or y, it doesn't matter, I'm going to multiply equation 1 by 2, and I'm going to multiply equation 2 by 3. That will mean that I have a common coefficient for my y variable. I chose to work with my y variable because those are smaller and more simple numbers than with my x's. No other reason. You could choose to work with the x's if you like. Now, when we do that, we end up with the equation, or the equations, plural, that will give us 8x plus 6y equals 34. Second equation, what was 2 will turn into 15x plus 6y. If those aren't the same, you've gone wrong. Equals 69. Once you've done your multiplications, one of your variables should have the same coefficient. I chose to work with y's. You may have chosen to work with your x's. Now, again, I need to subtract something. Now, just to keep it simple, we'll do the same thing as we did in the first example. So I'm going to subtract my second equation from my first. Now, when I say second, though, I am referring to the second set, my new second equation, my new first equation. You could relabel these as equation 3 or 4 if you prefer. It is completely up to you. It's a relatively arbitrary naming system. You can choose what you prefer. So, using my same system, that will leave me with 8x plus 6y equals 34. Subtract 15x plus 6y equals 69. Lay that out as a subtraction, and of course we will end up with negative 7x from 8 minus 15 of my x's. 0y, again we must be getting something as a 0 here, and that will all equal negative 35. Note that both of these did end up as negatives because both of these numbers were larger. If you would prefer to avoid that, simply subtract equation 1 from equation 2. The order doesn't actually matter. So, negative 7x equals negative 35. Again, we're just simplifying the result of what we had before, and that means that x equals 5. We're at the same point as what we got up to here. Now, like before, the final step is to substitute, and in this case we are substituting x equals 5 into any one of these 4 equations that we have here. It doesn't matter which one you choose. For convenience, I'm just going to choose the first one. It's the first one that we could refer to. You can pick any and check that you get the same answer. 4 multiplied by x now becomes 4 multiplied by 5 because we've substituted in what x equals. We still have 3y and we still have 17. Oops, So simplifying this leaves us with 20 plus 3y equals 17. Tidy that up one step further by moving my 20 to the right hand side. Gives 3y equals negative 3. Final step is dividing by 3 so that we see that y equals negative 1. That all being completed, the only other thing that I can do is communicate that the solution is at x equals 5, y equals negative 1. Done. Completely up to you which method you choose for any given problem, but some methods do lend themselves to particular questions.